Hey everybody, it's Lynette Schaefer, and in this lighting controls basics number 4, I'm going to be going over lighting control strategies. So the very first question you should ask yourself is, what does a customer want their lighting to do? Too many times I find people jumping right into how the controls install or what components are required, or they just take a bill of material and they try to cross it over. But in reality, it's really nearly impossible to do this without knowing what the customer wants. So with any lighting control system, it's really critical to have a good design intent, which addresses what the customer wants their lighting to do and confirms that it can be achieved as well. It also ensures the system produces the right amount of light where and when it's needed. Additionally, it ensures project requirements can be met with the most amount of flexibility. The benefits of having a good design intent is that it helps to achieve the maximum amount of energy savings. It also helps achieve budget requirements, and it helps reduce surprises or on-the-job changes, which can be very costly, as we all know. Now, a solid design intent also allows you to work out the issues before it's too late. So then the question is how do you achieve a good design intent? Well, first, it's important to understand that various lighting control strategies exist. Now, according to energy.gov, the most common types of lighting control strategies are dimmers, motion sensors, occupancy sensors, photo sensors, and timers. Now, I'm guessing many of you may already be using some of these lighting control strategies in your homes today. Of course, lighting control strategies have evolved to include other things besides just dimming, sensors, and timers. As a matter of fact, the most common lighting control strategies today include occupancy sensing, vacancy sensing, high-end trim, daylight harvesting, scheduling, zoning, creating scenes, personal control, individual fixture addressability, and continuous dimming. And we're going to deep dive into each one of these very, very soon. But first, you might be wondering why lighting control systems no longer just include dimming, motion sensors, photo sensors, and timers. And a big reason for that is the lighting industry has evolved from wired solutions to wireless solutions. So if you take your home, for example, if you're using a traditional dimmer switch, when you press the button on the dimmer, the signal travels through the wire to the lamps or the light fixture to dim the light source. The signal travels through the same wire that is providing power to the fixture, and we refer to this as line voltage or triac dimming or phase dimming. This is very common in residential applications. Now, in commercial applications, they actually use 0 to 10 volt dimming in a lot of cases versus just your standard phase dimming or triac dimming. That means additional 2 wires are required, which are reflected here with the violet and the pink line. So yes, with 0 to 10 volt control, there are actually 2 additional wires. This is very much unlike wireless solutions. In these cases, you still, of course, have to have power to the lamps or the fixtures, but now the signal travels wirelessly using communication protocols like Wi-Fi, Zigbee, or some form of Bluetooth, which opens the door to not only more lighting control strategies, but it also allows for the ability to easily layer various lighting control strategies and incorporate third-party solutions like BMS, which stands for Building Management System Integration. Additionally, you are also going to notice that the control device does not get wired into the circuit like it does with triac or 0 to 10 volt dimming, because remember, you are no longer sending the signal through wires. The signal is being sent wirelessly through some kind of wireless protocol. So for today's training, we really want to deep dive into the different lighting control strategies. As I just mentioned, these are the most common types of lighting control strategies, but believe it or not, there's a lot more. According to the DLC's website, there are 22 performance characteristics that can be achieved through various control strategies. Now, DLC, of course, stands for Design Light Consortium. Their members, which consists of a lot of different manufacturers and whatnot, and utility, or I should say more utilities than anything, but their members work together to drive product performance and consumer trust to save energy and improve quality. Manufacturers have to meet strict requirements to achieve DLC approval for every single product SKU. DLC also drives lighting control integration. Now, as I mentioned previously, the most common lighting control strategies include having the ability to set high-end trim, being able to have personal control, having occupancy sensing, including vacancy sensing, daylight harvesting, dimming, scheduling, and scene control. Of course, zoning and individual luminaire addressability have recently been getting a lot more attention, especially because of network lighting controls, in addition to being able to change the color or tuning the light. So next, we're going to dig into each of these highlighted lighting control strategies. The first one is high-end trim, and it sets the maximum light level and wattage output of the fixture. The reason people like to set high-end trim is for energy savings. In reality, the human eye can barely distinguish between 100% light level and 80% light level. So setting lights to 80% reduces energy use by about 20%. If you put this in terms of foot candle levels, that would basically be going from like 50 foot candles down to 40 foot candles. Now, let's say you have an office that has 33 lamp T8s. Typically, you would need a 40-watt fixture to achieve a similar light level. And here's an example using EiKO's payback calculator. You can access this tool at eiko.com. But with this example, the payback is about 3.3 years without rebate. And with the rebate, you get about 2.1 year with rebate. So now let's say, though, the fixture features EiKO's power set. And this, of course, allows the installer to easily select the maximum wattage upon installation. And now instead, the installer sets the maximum output to, say, 30 watts versus 40 watts. The payback now goes down to 2.7 years. Once the fixture is set to 30 watts, it will never use any more watts than 30 unless the switch is moved to 40 watts. When you reduce the watts, you reduce the amount of energy being, which means that you also reduce the lumen output and you save energy. Now, similarly, there's also something called low end trim. This means the fixture will never go off and is used in a lot of stairwells and other areas that require light, and especially in areas that require light 24/7. Now, high-end trim can be incorporated into projects by purchasing products that have, of course, power set, or you can also utilize high-end trim and low-end trim by utilizing network lighting controls, because that allows you to set the maximum brightness, or you can also set the absolute lowest the fixture will ever go by using the app. So it's really nice to be able to have that feature when it comes to network lighting controls. So next we have personal control, continuous dimming, and scenes. Personal control means that an individual user can adjust the light in their space, in their personal area, the way that they want it. So this is easily accomplished when you have, say, maybe a small office. Of course, you can do that by just having a switch on the wall. But in those cases, where you have maybe a large open cubicle area with a number of desks, it's a little bit harder to get that personal control. So in this case, a dimmer on the wall doesn't really work because you wouldn't have that personal control for each person at their specific desk. So instead, you would want to perhaps maybe include something like EiKO's network lighting control solution or a network lighting control solution so that you can achieve that personal control at each of the desk. And you would basically do that by incorporating switches and having fixture controllers in each fixture. Now, continuous dimming usually is referred to as dimming. Some people just call it dimming, right? But it's the ability to smoothly increase or decrease the light intensity as opposed to step dimming, which is jumping quickly from one light level to the next. So for instance, jumping from 50%, say, to 100% immediately is more like step dimming. Continuous dimming is being able to smoothly dim the lights. And then the last one here are scenes. And scenes provide 2 or more programmed light levels. It can sometimes be up to 4 or even more than that. But let's just say in this example, you program this particular controller. This is a wireless controller, and the top button, you want the fixtures to turn to 100% brightness when you press it. You can do that. Let's say the next button down, you want the lights to maybe go to 50% when you press it, you can do that. Or maybe they go off completely, or maybe the third button here, maybe they turn on to 25% brightness. So there's a lot of different options. Now, scheduling is being able to have the lights automatically turn on or off at certain times. Basic scheduling can be achieved through using time clocks. Of course, more sophisticated scheduling is achieved through utilizing some form of network lighting controls. Now, yes, there's a lot going on in the slide, but direct your attention to the animation on the left-hand side. Daylight harvesting in this example is when the sun comes up, the light level gradually increases or decreasing to maintain a certain light level. With daylight harvesting, there are a few things to keep in mind. Number one, it doesn't have to be sunlight. It can be light from artificial light. The sensor is just looking to maintain a required light level. It doesn't care where the light is coming from. Now, the sensor can trigger the lights to shut off if the light is, if the light level that they want it to achieve is too high. The sensor will just tell the fixture to, hey, shut the entire fixture off. If not, it will continue to increase and decrease to maintain a light level that is required. This is very much unlike ambient threshold. With ambient threshold, the fixtures are either on or off. So if the sensor sees that there's enough light in the space based on a specified light level, the fixtures will shut off. And then when the sensor does not see that there's enough light in the space, then of course they're going to turn the light fixtures back on. There are some sensors out there that actually have two sensors built in one. This is sort of like an ambient threshold plus PI or IR for infrared. One sensor is just looking for any type of lighting. The other one is specifically looking for only IR or daylight type of lighting. It just depends on the type of technology that you have, what sensor you have, but just know that there are sensors out there that have both ambient threshold with IR built in one. Now, daylight harvesting and ambient threshold can be incorporated into projects various different ways. Of course, utilizing a network lighting control solution makes it super easy. So it's always nice to be able to have that if you are looking at network lighting controls and if you're looking at doing any type of daylight harvesting. Now, the next lighting control strategy are occupancy sensors and vacancy sensors. The best way to explain this is by showing another animation. So here we have an example of an outdoor fixture. Someone walks near the fixture, the light turns to 100%. After no motion, it then dims down to say maybe 30%, or it could potentially just turn off entirely as well. Just depends on how you have it commissioned. Either way, occupancy sensors, they do not require anyone to physically press a button. They automatically turn on and will automatically shut off when there's no motion. That is very much unlike vacancy sensors. So with vacancy sensors, the occupant needs to manually turn the lights on when they go in the space. Once the person's in that space for a period of time, then they leave and there's no motion. Then of course the light fixtures will either dim down to a certain level or just fade off or turn off entirely. Just depends on how you have it commissioned. Again, you have to go in, flip the switch to turn the fixtures back on. Once you have that, then after no motion, then they'll turn off. This type of sensing is becoming more popular because it eliminates false triggers and it provides the greatest amount of energy savings. Plus, some of the codes nowadays actually require this to be used as well. It just depends on where you're located at. Individual fixture addressability requires each fixture to be individually controlled. The benefit of having fixtures individually addressable is that you can easily create groups or zones, and you can also change them at any time. So you can have, zone 1, zone 2. You can maybe say, nope, you know what, I want to change this. I want these 4 fixtures in this group to work together. You can do all of that with the ability to create your groups and your zones. And what's great about network lighting controls and wireless controls is that the circuitry at this point, the circuits and the wiring really doesn't matter because it's all wireless. The last control strategy is the ability to change the color, whether that's through color tuning or color changing. Color tuning is when you change the CCT of the light. When you are looking here at the chromaticity diagram, this black line is the black body locus or the black body curve. This black body locus or curve is where white light is located. And that white light can be changed from, say, very warm 2700 Kelvin all the way up to a very cool, say, 5000 Kelvin. The ability to change the CCT can be achieved through EiKO's field set products, which of course just allows the contractor to select the CCT upon installation, just like PowerSet has little switches on the lighting fixture or on the lamp. However, some manufacturers do have the ability now to change the CCT remotely through their form of network lighting controls. Color changing is the ability to change the color. Think of Christmas lights. This allows you to kind of maybe highlight the side of a building and change colors based on whatever the event may be, whether it's the holidays or whether it's St. Patrick's Days or whatever. It gives you more flexibility. Today, currently, EiKO doesn't offer anything with color changing. However, there are some manufacturers out there, if you're specifically looking at the ability to change the color, there are certain systems out there that will allow you to change the color. Just you've got to look for those that offer that type of feature. So in summary, the most common lighting control strategies can be incorporated into projects in various ways. So for instance, if your customer just wants to achieve daylight harvesting, you can do that with a basic standalone sensor, or you can also do it through network lighting controls, or you could just simply buy a fixture with a built-in photocell. Just depends on what your customer wants to achieve, right? For occupancy sensing, this can be achieved with standalone sensors or, of course, a network lighting control solution. High-end trim can be achieved by a standalone or network lighting control, or you can also just buy fixtures that have PowerSet and adjust it via that way when you go to install it. When it comes to color changing or tuning, you can easily purchase field set products, which gives you the ability to select the CCT upon install. Or as I mentioned, there are some manufacturers that offer color changing or color tuning through their form of network lighting controls. Vacancy sensing, continuous dimming, and also scenes and personal control. Those can all be achieved by incorporating basic switches, or of course, you can also, go ahead and go with a network lighting control system. And of course, scheduling can be achieved by incorporating a simple timer, a time clock, or of course, also through network lighting controls. So you may have noticed the only lighting control solution that can achieve nearly all lighting control strategies without a number of individual components is a networked lighting control solution. We call this layering lighting control strategies. Many people require a layering of control strategies in the same space to satisfy different energy codes and also to satisfy the customer's requirements. So for example, in an open office, maybe you need manual control or personal control. You might combine that with daylight harvesting and maybe with high-end trim. Specifically, EiKO's network lighting controls enable multiple strategies to be combined in the simplest and easiest way. So you can basically get almost all of these things with just one solution, rather than having a bunch of different solutions that you're trying to make work together. Now, what network lighting controls can also do things like energy monitoring, which basically tells you how much energy the lighting system is consuming. Many energy codes are also requiring plug load control, which is referred to as automatic receptacle control. This is more common when it comes to switching off computers and copiers and other things that draw energy when not in use. But it is also starting to be introduced as it pertains to lighting loads, similar to load shedding and demand response. Additionally, remote diagnostics is always nice because it allows people to know exactly what fixtures need maintenance. And it will also sometimes take you through the ability to check if you have any emergency battery backup type situations going on. It'll tell you and alert you if they need to be checked, or if something's not working properly with them, rather than having somebody go out and check those every 30 days. And of course, you can also have the ability to link into HVAC systems and other building management systems. This is also becoming more popular. So network lighting controls really open the door to so many things besides just your basic lighting control strategies. Thank you for joining me for Lighting Control Basics number 4. If you have any questions, you can certainly email me at lynette.schaefer@eiko.com.